Hello everyone, and today it is the eighth video of our series on UPSC Civil Service Mains questions, and this is the eighth video. And as I've told you yesterday, that today we will see some power plant question numerical. So there was one question of power plant with regenerative cycle. So what the question is, let's see. In a single liter regenerative cycle, steam enters in the turbine at 30 bar and 400 degrees Celsius. So that is the condition one here. I have drawn the TS diagram also over here. And exhaust pressure, that means condenser pressure, is given as 0.1 bar. The feed water heater is direct contact type and which operates at 0.3 megapascal, that means it is 3 bar. Okay, find the efficiency of the cycle neglecting the pump work, and at 30 bar 400 degrees Celsius enthalpy is given, and also use the steam table. Okay, so here whatever the I have value taken, so that is from steam table. So to save the time I have written down the value, but from where and which point I have taken, that is also written. So first of all, let's see the TS diagram of here. 0.1 turbine entry at 30 bar, and after extraction at 0.2, that means at 3 bar, some amount of it is extracted, and whatever the analysis, it is based on our 1 kg analysis per kg mass. So 1 kg of steam is entering, and now fraction of that, that means F, is taken out, and at 3 bar from regenerative feed water heater, and after the remaining 1 minus F, this 1 minus F is directed towards the condenser, and whatever work is produced, that is called turbine work from here as well as from here also. Now at 0.4, this is condensation. 0.5 pumped to 0.5, and then it is directed to 0.6, and then again pumped to 0.7 and to the boiler finally. But here pump work we have to neglect. So now we will find enthalpy of all the 7 points, so that our question will be quite easy, because whenever the power plant question is there, so try to find out the enthalpy at all the points, not all, but all the relevant points. So here H1, that is H1 enthalpy 3230.9 kilojoule per kg already given. Now H2, that means at 0.2 here, sorry, 0.2 over here. H2, that is Hg at 3 bar. Hg, that means enthalpy of vapor, saturated vapor. So it is from steam table at 3 bar 2737.69 kilojoule per kg. Now to find the at 3, first of all we have to find the dryness fraction, because it is in wet region. So isentropic expansion equation, S1 is equal to S3. S1 value is also given, and here we know that SF plus X into SFG, but this equation at 0.1 bar, values of SF and SFG. So SF value and SFG value here I have written, and you can see the dryness fraction is 0.93 comes out to. Now H3 is what? HF plus X into HFG at 0.1 bar. So from steam table, HF value and HFG value, both the values are here, HF value and dryness fraction and HFG value. So it is 2521.73 kilojoule per kg H3 values. Now we have H4. H4 is what? At 0.1 bar, value of HF, that means enthalpy of fluid, liquid, H4, and it will be same H5 because we have to neglect the pump work. Now H6 is what? Enthalpy of fluid, HF, at 3 bar, intermediate pressure. So it is 604.656 kilojoule per kg from steam table, and similarly it is same for H7. Why? Because we have to neglect the pump work. Now here water feed water heater, or you can say that regenerator. So F amount of fraction of steam is extracted at condition 2, and the 1 minus F is coming at the condition 5, and 1, that means total 1 kg steam is extracted at the condition 7. So H6 is equal to H7. So using the energy balance equation of first law of thermodynamics, so 1 kg of steam at H6 enthalpy is equal to fraction of steam at H2 enthalpy plus 1 minus F into H5. Okay, so all the values we have. Now put the value and you will find the fraction, that is 0.055. Now what we have to do is efficiency that they have given. Efficiency is what? Network upon heat supply. Network is what? Turbine work minus pump work, but pump work we have to neglect, so it is 0. Turbine work is what? From figure here you can see H1 minus H2. Here up to this 1 kg of steam is there, plus 1 minus F into H2 minus H3. Here you can see in the diagram H2 minus H3, but at 1 minus 5 kg of steam, and H1 minus H7, that is heat supply. That is heat supply from here QS H1 minus H7. So when you put all this value, because we have all the enthalpy value, so you will get the efficiency is 26.55. This question is not that much tough, but in the real examination, you have to find the value from the steam table back on the last page of the paper. So to find the value from here and there, at what pressure, at this point 3 and 3 bar. So somewhat we have to do the interpolation and find out the value that is not given, exact given. So you have to find the interpolation. So that interpolation and finding out the values from steam table, that is a time consuming process. Otherwise this numerical is simple. So try to do this kind of example, and try to solve the question in such a way that you will take the minimum time while finding the enthalpy from steam table. So this is the main thing that we have to keep in the mind. That's why this question has 20 marks weightage. So thank you for watching today's video. I hope you like this. Tomorrow we will meet with a new video. So till then, uh, keep studying, stay healthy. Thank you for watching, and like this video and share this video with your friends also.